Hi, in this video I will show you how to create an excavator bucket for the Caterpillar 474, which is the one of the largest common use Caterpillar excavators. And this is the first episode from the series in which I'm making the excavator called as 374 Caterpillar. So we will start from import a file. So now create a new file and import an image to our file which represents the template. I must import this, and by depending on this template I can make the real version of this excavator without usage a common path through mistakes. So now, as you have the excavator here, it's time to calibrate this to real dimensions. Click on calibrate button and apply dimension in this case length, and this is in real world example 30 meters and 652, so we must specify 13,652 millimeters. Okay, now picture is definitely bigger, and click on OK. We have everything calibrated. Now we must switch to making this excavator bucket through suitable workbench. Switch to part design workbench. For us is this necessary because we will make a new part, the excavator bucket. Create body and make a sketch on subsuitable plane. In this case we have three, commonly are three. So to determine your axis you must look on your axis pointer is here, and keep in mind this for us is Y, X, or in a reverse order, so it's I plane. Click on OK, and now let's switch to make this bucket. So to make this bucket you must run over the image, and keep in mind that this is the center location point and this is not through all length of bucket, so you must switch this. Also in real world this part is welded to bucket body. So as I said, we must also determine the smooth point of connection for these two. These are external parts to which you must make the suitable coordinates and assign these coordinates to your bucket. So switch to B-spline and start make a bucket. I made the mistake. So must switch this to let's say here is the endpoint for the B-spline, switch to polyline, and define the smooth point. Remove redundant constraints and adjust this point to be as smooth as is the best. Also, you can adjust the B-spline and connect points. In this FreeCad version, which is 0.21, the sketch must be connected. So, and we can move and see that here is also without connection. Once again, connect point to point and click close. We have made a sketch. Hide the image and use the sketch. When it's selected, is highlighted the specific color. In my case, this is the green. Depend on your configuration or about your color of program. So here determine for extreme edition of Caterpillar 374 Excavator the dimension for bucket. This is 2 meters, so 2000 millimeters. You have here. Oh, I made mistake. This must be thinner here. So here is not great. So let's switch to sketch. Change this. This must be thinner, definitely. Like in this case. Like here. Close. Okay, we can stay with this. Let's check how this looks on real world case. Okay, this is fine. This is fine. Okay, but we must also adjust one position here. Let's add here. Point. This is not possible. So an error. Error here. So additionally, we can extend this body to make ones more complex. Switch here and define the point up to here. Remove the unnecessary lines. Yes, we have connection. We have connection. To move with those which are the part of, you must use the image. And we have the constant construction. Now it's time to define this this pin plate. And let's use the line here. Say this to this. Now use B-spline to connect this. This case same. More smooth. As has occurred. And remove everything which is outside the sketch. So through trim. Trim this, 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 this. Everything is trimmed. We can stay with such construction, I think. Something is wrong here. The external point exists here. But something wrong with that. Wire is not closed. Wire is not closed. Here is closed. Here is also closed. Let's move wire. Wire is not closed. Here is closed. Here is also. So where? Here is closed. Closed again. Refresh. Wire is not closed. Here is the problem. Trim this edge. Close. Still. Also check again. So we have the basic bucket construction, height image, and now let's make the pocket. The pocket, which is the ability to fill the bucket, is made through iterating over here and determine the thickness of material, and then here connect here to make the gap. Now switch to part workbench and make the cut operation. Bowling operation cut. So switch to create sketch, pick the plane. You have the Euro construction, so use view section to make only section visible for you. And now determine the lines through P-spline and determine the start point. Start point here is over here and iterate over your parts. Make the thickness based on my eye, as God gives me eye to make everything on eye. Okay, and here connect. We have connected. Now let's make the construction. Hide these pockets. Make sure that you have select your sketch and make this path. And determine the thickness for your path. This will be 2 meters with 40 millimeters, because we need the 2 centimeters of thick for each wall, left and right. This is great. Okay, and now we have the basic construction. Now we must transform this to center position, use the transform, and determine here the movement. For me, this movement will be about 20 millimeters, so one wall thickness. And again, I have accidentally quit from my view, and now it's not visible. Transform. Let's move forward in the dimension. Oh no. So create additional body and move this path here. And move sketch here. So once again, make the sketch visible and switch to sketch here. Go draft and clone operation. Which is there. Like this. Move also this. 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 And once again, same operation for this. I must make this in such way because the bowling operation works on separate bodies, and also my construction cannot be determined as separate paths, not in this version of FreeCad. So make the path again using part design and separate this as 1960 millimeters. Now again body, transform to movement body. Over to 20 millimeters, and you have 2 centimeters here and 2 centimeters here. Okay, now we can change color of this body. Let's say orange, and here to black. And we will see everything black on. Once again, orange on black. Now use workbench and make the cut. And we have our path and our bucket made. Now we can make the color again white. White is the most clear color. And we see. Now turn on the image and make now the mount part. But we will start from here and creating this in the center. I can also switch to real world case, how this looks. So we'll pick here, put on here the cutter cut for 374. Expand that copy bucket, and we can see that with the AI picture, and we will see that this is the two separate parts, and we must put these two separate parts. So this is this image. Let's make this. So switch to the part body, part design, create body. Rename this body to mount part, and now let's make this. We will base on this bucket. Let's say we will start here and we will end here. So mix your sketch, and using this spline from point, firstly let's use the now for construction. I should have it here. We are out of the connection preferred spot. Oh, I'll define this to this position. Let's move here. And we will move the hatch here. Point. Remove the unnecessary lines. Routine ring tool. Now make the holes. Determine the circle dimension. 22 centimeters is nice. And lovely placement. We'll use a construction line. This on this construction line. Once again, stay in this position, close, and now make the path with thickness 10 centimeters. And let's move this to the center. Also, let's define the gap for this both. So this should be in center, and the placement, the gap between these two should be half meter. So let's say the mathematical main. Let's move this from 0 once again 162 minus 50 plus to 50 millimeters. Okay. And once again, now let's repeat this by using the inner pattern amount part, or I prefer to use the draft and use this by usage array linear pattern, and towards the axis this will be 1, 2 elements, towards the axis 1, and here also 1. The Z interval should be 50 centimeters. 500. Let's move this. Let's move this to the center. Nie przeszkadzaj, nie przeszkadzaj, przeszkadzasz. Wpierdalacie się. Wiecznie się wpierdalacie. Transform to the center. This must be the alien center. And this is the correct result. Let's move 9. We can move like this. Like this without any gaps between elements. Okay, it's okay. And now to make the one from these two is, as I said, really worthy to make the thousand operation in part workbench. It's called as union here. We must, the object is not allowed. So so this will act as one element. I can move this everything as one element, not as separate ones. Each separate part would stay in separate position. Separate. Now we might make a diffs to this excavator. We can also check whether this is great. I think this looks fine for us. This is the 3D model, real case examples can transform pretty much. Also, I have not thought about how this should look before a lot, so we will stay with this. And now let's make a thief. We can make a thief and separate. Now make for this bucket. Now break thieves to bucket. I can make this by part design once again. This side using for this polyline. So is both sides. So here, okay, so that's our tips, and now I can make the union. And we have now the bucket with tips. So now we should make the internal tips. The tips are only on back side, attached to back side. Height body and make the height as, let's say, that this will be the 200 millimeters, and the width will be 390. Also redefine the circle. Okay, and we have the profile here. Close and hide the distance parameters. Rename this to profile. Hide window. And as we have a profile, in this position we must put this below the y-axis. So again, switch to your profile, copy this whole sketch, use sketch tools and select copy tool. Use copy tool. And this sketch must be removed. Put this sketch in this spot and use here the vertical constraint. So now we have, and next step will be creating the helpline, because this will shrink toward x-axis. So I must start with helper. Hide origin, and helper will be through this spot. So my sketch, depending on this axis. I think it's fine. Again, let's make this sketch. Okay. So when we cannot, I should support myself by usage of button plane. So this my button plane. Onto a surface. This surface. Oh, I know why. Why we couldn't make. I have not selected body. Now it's selected. Now I can make the scans depending on my desired plane. And this is fine. So as I have here our origin. I must select the path, which will be straight line toward our desired axis. Set up your length. As I said, should be similar 490. This is 25 millimeters. Let's give here 20 millimeters. This is the helper. So close. Let's name this as helper. Helper top. Now use button plane. Use button plane on this axis. And select our desired path. Reference and select this path. Can be selected for some reason. So again, select this plane. Go here and now select the line. Or select this. Select this line. The line, but the rotation is wrong. So let's move around. Let's move around x-axis. This is the correct placement. And now use this datum plane as helper to create the profile. Adjust datum plane. Move towards that direction. Again. height, move down. Now it's fine. One side further is not. Move even further. Now less hue. Okay, it's fine. Switch to sketch. We have everything selected. But reselect this again. Close. Now we have our sketch. So now we should check what we will get depending on our job. Possibly this can be a malicious. I'll select every line which is necessary for our construction and create a part array. From some reason the area is too small, so I must remove this helper tool, bottom top line, greater use without this helper top line, shape structure, simplify helper tool. Okay, now we have to check the solid construction. I should unwind, roll up the property panel and change the value solid to true. And this is some kind of accuracy. To give more accuracy, you should increase the items number to 100. As can be an example. I increase exactly to 1000, so potentially this can crash the program. This is too much. As much as you can see artifacts. 100. Let's say 100 is great. And as you see, this is nice. But we have this fillet. How we can change this fillet? We can from the shape part design through binder. And we can utilize the curve workbench to make the construction, but one additional line must be applied to the construction, so make sketch enter. This I name as for the bucket of thieves. And move this to position to transform operation. Try the original version. Select this and select this and this. Switch the part. Include cut. To have a cut quotas. Okay. Let's say the internal will be about, because we need to replicate this through the excavator, and also you can observe that the shape is not ideal. It's for this use case. Okay, let's switch to draft and array. We must define. So this is the our result bucket. Thank you for watching, and see you in next videos from this series.